Good morning, this is Losfeld, and today we're going to talk about reverse clocks, okay? Last stream I said a few things that I thought, well, I had never said those things before, because they're a little bit too in-depth, and so if you're just starting out with air roll or with the method, I would advise just stopping this video right now until maybe 1 week in, at least, right? So, reverse clocks. Let's talk about those in a way that hopefully you'll understand. As I usually say, air roll is about three things. It's about what input you press, how long you press it for, and how fast you press it for if it's continuous inputs like reverse clocks, right? Now, let's talk about the basics first. When you press an input, whether directional or non-directional, so either the up inputs or the down inputs, or tornado spin, reverse tornado spin, the non-directional inputs, your car is going to turn two directions. It's going to take two vectors. For instance, if I go down on my joystick, my car is going to go up and left. If I go up, my car is going to go down and right. Okay? And when I say those things, I mean the beginning of the movement of the car. That's the most important part. It's the beginning of the movement of the car, right? Now, the reason, again, why my car turns left or right when I press up or down inputs is because it's going to lock either the front left and back right wheel or the front right and back left wheel. That's why I turn when I do this, and that's why I don't turn when I make a tornado spin, because when I make a tornado spin, the wheels are not locked. That being said, what you can do with reverse clocks, and the reason that there's many reverse clocks depending on the rhythm at which you do them, is because depending on how long you stay on an input, you will cut one of those two vectors. Let me make you understand that. In order to understand that, we're going to come back to coxer twists and tornado spins, right? Remember, when you hold an input for one revolution, whatever the input may be, your car is going to turn on its own axis, right, in a certain direction. It's going to make that spiral movement, right? It's not, so here I'm not pressing air roll, the car rotates, right, on one axis. And then when I press a button like tornado spin, for instance, my car is going to start making that spiral movement with the rotation. Okay? Now, why do I say that? Because when you make reverse clocks, when you make slow reverse clocks, for instance, what you're doing is that you are letting the inputs one by one start to get the vector of the rotation that it would take in a coxer twist or tornado spin. So when I go down, right, up slowly, the reason I turn left is because I'm giving enough time for the inputs to give me that turn. Now, what you can do when you make a faster reverse clock, let's take the same one, down, right, up, is that you will cut one of the vectors. So every time you do a fast reverse clock, what you do is that you cut one of the two vectors that the inputs are supposed to give you, right? So if I go down, right, up quickly, instead of going to the left, the vector going to the left is going to be cut, and all there is left is going to be the up inputs, right? I mean the up vectors, not the up inputs. So if I go down, right, up slowly, I go to the left, okay? But if I do it faster, I'm going to start to get vertical because I'm going to cut the left vectors out of it. So imagine it's like it's like a fan, like this. It's like a fan, and you can cut the vectors that you want to take. If I do it even faster, I'm also going to cut the up vector, and so I'm going to start going to the right. So if I do this, I start going to the right. The reason it does that is because I spend so little time on the first inputs that basically when I come to the up portion, which makes me go right, my car is almost neutral. Hence, the first input that I make down and the other inputs that I make when I get up are also on the neutral revolution. Okay? By the way, you can, in one reverse clock, you can change the rhythm. So for instance, if I do this, for instance, and then see what I did here is that I started doing a reverse clock and then I held on to the reverse tornado input. I started turning. Why? Because again, when you hold an input for long, it starts to rotate. So what you do is that when you do a slow reverse clock, you're kind of enabling the vectors to go. But the faster you do them, the less the vector is going to appear. So when you start with a down input, for instance, slow is left and fast is up because I'm cutting the left vectors. And it's the opposite for tornado spins and reverse tornado spins, meaning that when I do slow, I will start to go up. Why? Because the input, when you hold the right input on left arrow, you make a tornado spin, which means that your nose is going to go up. But if I do it quickly, though, I'm cutting the up input because the car doesn't have time to go like this. So I'm cutting the up input, and so all there is left is what? The other horizontal input, which is right. So if I do a fast reverse clock from right, I'm going to go to the right. Okay? I thought that was interesting to show you guys so that you kind of understand. What I mean is that the reverse clock, they overlap one another depending on how fast you stay on the input. You understand? They overlap. It's like this is a slow reverse clock, and these are your vectors, left vector and up vector. The faster you do the reverse clock for, so the least amount of time that you spend on inputs, the more the reverse clock is going to overlap the vectors. That's what I mean by cutting vectors. Do you understand? So if this is a slow reverse clock from down, and this is a fast reverse clock from down, this is going to make me go left, but as I do it faster and faster and faster, I'm going to join the upward vector. And again, if I go even faster, I might turn slightly to the right. Okay? So of course, you can fiddle with those inputs less or more depending on how long you do them for. That's why if I only do a half reverse clock from down, I'm not going to get totally vertical from horizontal, but I will get verticality. If I want to accentuate this vector even more, I continue doing the reverse clock with the same speed. And so what's going to happen is that I'm going to do basically a 180. Okay? So I just wanted to showcase the cutting vector aspect of the reverse clock, which is the reason why you can take many directions while doing the same thing, but at the same inputs, but with a different speed on each input, which I call rhythm because it's within the revolution from the neutral revolution, which is the tempo. Okay, I hope you understand that. This is why if you're just starting out, you might not understand any of what I just said. It's fine. It's just my terminology, but my terminology is not very complicated, to be honest with you. So yeah, understand that reverse clocks overlap each other depending on how fast you do them. And when I say they overlap, it's because if you take two extremes, if I want to put things in boxes, which is the right thing to teach, let's say you do a slow one. Again, let me show you that again. This is a slow reverse clock. This is a fast reverse clock from down, the down input, whichever air roll you're doing. If I go slow, I know I'm going to go left. If I go fast, I know I'm going to go up. And why? Because as the faster I do them, the more the reverse clocks overlap each other. It's like I thought I was going to do a fan, but I think that this is overlapping thing might help you, right? So now let's talk about little, it's not another thing, but during my stream, I started making noises to make people understand the rhythm. So for instance, if I go bam, 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 1, 2, 3, 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 bam, 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 I go left. Now, if I go bam, 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 so the first one was bam, 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 and then I go bam, 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 1, 2, 3, 4, 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 bam, 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 1, 2, 3, 4. See, I'm going vertical. Sorry if this was infuriating for you. So that's what I mean by rhythm. Of course, you don't need to go down, right, up. Like specific, you don't need to go down, right, up. What I want you to do is go with a smooth down, right, up, right, on the joystick. Not a down, right, up, down, right, up. No, I want you to go down, right, up. Okay? And so if I do let's say if we come back to the old rhythm, the slow one, bam, 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 bam. If I keep holding it, bam, 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 I'm going to make that spiral because I'm letting the inputs start to do cuts or twists, but I still stop them. And now if I do the faster rhythm, but I do more than half reverse clock, so I go bam, 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 right? I'm going to go bam, 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 bam. 1, 2, 3, 4, 5, 6. Bam, 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 bam. Bam, 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 bam. Vertical. Okay? Good. I hope that was clear enough. Forgive me if it wasn't, but I hope that was clear. Reverse clocks, depending on how long you do them for, overlap each other because for each input that you're going to press in left arrow, or I mean in directional arrow, your car is taking two different vectors at first. So if I just hold, again, let me repeat myself a little bit. If I hold one input, I'm going to go two directions. So here, my nose starts going down and right. The reason it goes down is because it's an up input. The reason it goes right is because the wheels are locked in a diagonal. And we're just talking about the beginning, not the whole coxer twist or tornado spin. We're just talking about the beginning of the movement. That's what we're talking about here. Let me make that important, clear. Okay? So, the two vectors, you can cut the vectors. You can cut one of those two vectors depending on the speed at which you do them. Simple, right? And then the reverse clocks start to overlap each other. Good? Is that good for you? Is it good for you? Is it good for you, man? I hope it's good. It's good for me. Okay, I hope you like that. I wanted to make some paint charts and all that, but I thought it was a bit too complicated. And I think me showing that they overlap. So you take two vectors, right? So if I press up, I'm going to go like this. Let me do it. No, let me go left in your direction like that. When I go left, I go up. When I go down, when I go down on the input, I go up and left. If I do it faster, I'm going to cut out the left input and I'm just going to be staying with the up vector, right? So I said left input, I mean left vector. And so when I do it faster, I'm going to cut out the left vector and there's only going to be like the only thing that's going to be staying in this equation is going to be the up vector. And that works on every input, of course, depending on, like, for instance, if I stay on tornado spin input, depending on which one it is, the main vector that will be cut will either be the up vector or the side vector. Let me make you understand that. If I go upright, which is a tornado spin, which is still on the tornado spin side of the joystick, at some point I should get my nose up, right? See, my nose goes up, right? Upright. So you see, my nose goes up at a certain point during the revolution. But because this input is more up than down, it takes longer, even if it's tornado spin side of the joystick, it takes longer to appear. And that's where the fan system comes in, right? So if the inputs are down on the joystick, your nose will tend to go up. And if the inputs are tornado spin side of the joystick, your nose will tend to go up. The difference is that the more you go upwards in the joystick, even if it's a tornado side input, the more you go up, the longer the up vector is going to appear. Do you understand? Whereas if it's a down input and a tornado side input, the up vector is going to appear really quickly. Do you understand? You understand? You feel me? Because tornado side spin of the joystick makes your nose go up at first, and the reverse tornado spin makes your nose go down. So if it's a down input, and for instance, a tornado side input of the joystick, my nose is going to turn up, even more so. Whereas if it's an up input, even if it's tornado side spin of the joystick, I'm going to have to wait a little bit. See what I did here? I had to linger on the upright input until the nose was up, and then I could catch my reverse clock and make me do a 180. You feel me? And the same thing happens The same thing happens with the tornado spin, as I said. You have to let the tornado spin appear. I mean, you have to let the nose appear up in the tornado spin before you do the reverse clocks. Once it's appeared, you can catch your reverse clock the same way you catch a clock, right? So that's why I prefer to, when I go up vertical, I prefer to start with a down input because I instantly go up. Whereas if I started with a tornado side input, I have to wait until the nose is going up and then do my reverse clock. Because if I started instantly fast, again, I'm going to go right because this is going to cut the up input. Is that getting clearer? I hope it is. If you have any questions, of course, the Discord is here and I'll be here on stream, but I wanted to make this addition to the reverse clocks because I've said it a few times on stream. I didn't want to make a video first about it because this starts to get a bit too much in depth, especially for new people. But I was told by my viewers that it was a good thing to do. So here it is. I hope you liked it. Feel free to ask your questions and all that on the Discord or during a stream. I will catch you next time. Losfeld out and goodbye in 3, 2, 1. Goodbye.